Okay, students, we kind of went over this PowerPoint in the face-to-face class, but I did not have a chance to review this PowerPoint with my online class. So my sincere apologies. Mr. Morris has had a lot on his plate since he arrived at Thomas Nelson Community College. We have already reviewed the syllabus and as far as the project goes, I'm still in the process of clearly defining what that is, and as soon as I'm done, I will share that with you. I have been creating videos as far as your homework goes to help you out in the course. So please come by and see me. The office hours were posted on the syllabus. So please stop by and see me, both online students and face-to-face students, if you need help. Also remember, you should be saving your work, whether you do that in way of a memory storage device such as a flash drive, or you save it to, or email it to yourself. Email your work to yourself. Okay? All right. So now, why does an engineer or a designer need to learn engineering graphics? Well, engineers need to be able to communicate with people in the field, machinists, technologists, craftspeople, a variety of disciplines. These folks need to be able to read the drawings. Okay, engineering drawings are not art, but they are technical presentations, and they should be presented they should be presented in such a way that they're cosmetically appealing, but at the same time they are technically correct. We use a lot of symbols, and there's a lot of rules and regulations associated with the engineering drawing. In this class, we're going to focus on CAD and also hand sketching. Now, we haven't done any hand sketching yet, so this is preview of coming attractions. And even if you're good in CAD, if you don't know the rules and regulations associated with laying out a drawing, then chances are you may or may not get a job. So the way you lay out your drawing is critical. A knowledge of CAD is one of the earliest marketable skills that an engineer or designer student might possess. Mr. Morris has been using CAD since the early 90s, and I will tell you that I've always been gainfully employed because of my knowledge of AutoCAD, Inventor, and other software packages like Solid Edge and SolidWorks, IBM CADM, and the list goes on. So when you learn one, the learning curve is not as steep as it is when you first learn it. So when you learn one, the learning curve is not as steep. Many engineers and designers use CAD on a daily basis. Engineers and designers will form sketches. So sometimes you have to go out in the field and make sketches on paper. You're never going to be able to replace hand sketching. And then they come back to their office and they download their data into the computer. So you make official drawings based on your sketches. However, the sketches must be technically accurate. For example, it would be unreasonable to expect a CAD operator to know how to lay out your drawing. So a CAD operator has to work closely with the engineer or designers to lay out the drawing in such a way that is acceptable, especially to the higher-ups, because they're going to be the ones signing off on the drawings. Okay? All right, so let's go to sheet 3. Drawings may be freehand sketches. They could be mechanical drawings. Now, that's a rapidly vanishing area. When I was taking CAD courses, or not CAD courses, but drafting courses back in the early 80s, we used T-squares and triangles and the drawing board and templates, circle templates, ellipse templates, erasure templates, all different types of pencils and scales, So we use all these drawing instruments. Well, they don't do much of that anymore. Very little of that is done. We focus mainly on computer-aided drawings. Computer-aided drawings can be two-dimensional. It can be 3D solid modeling and 3D parametric solid modeling. So we're going to be doing both in this class. Actually, we're going to be doing sketches, and we're going to be doing two-dimensional CAD drawings and some 3D CAD modeling. If you want to know where to find these rules and regulations associated with the drawing, the American National Standards Drafting Manual Y14 has all the information that you need to know as far as the rules and regulations. How do you lay out a drawing? How do you dimension a drawing correctly? There's a right way to dimension a part and a wrong way. And we will see that as we progress through the course. Sketching is perhaps better referred to as a freehand sketch or freehand drawing. Sketching used by engineers does not normally refer to artistic type drawings. Instead, sketching simply means freehand drawing without the drawing instruments. Sketches should not be crude, sloppy, or unclear. As engineers and designers and technologists, we're very neat. As opposed to a doctor, when they write a prescription, is very messy. So we're very neat. We want to be very clear. We want our drawings to be very proportional. And here I have a picture of a car. Perhaps we drew one like this when we were in first grade. Notice the wheels are very large. I've actually probably seen some of these on the highway. But we know that usually the wheels are more proportional to the car. So you would not make a sketch necessarily like this. You want it to be proportional. Also use proper line widths and types. We are going to learn about the various types of lines, and I would encourage you to go on the internet and look and find some information on the alphabet of lines that gives you a description of all the line types used on engineering type drawings. As far as graph paper is concerned, one site that I found on the internet that's very good is www.printablepaper.net. You can download some rectangular grid paper and some isometric grid paper. Okay? Now, let me zoom out just a little bit here. When you draw a circle, sometimes it's beneficial, especially if you're working with the rectangular grid paper, to create like an enclosing box. It makes it very easy to draw your circle in the box because you know the circle is tangent at each one of these points. Some people need this as a drawing aid and some people don't. Depends on how steady your hand is. If your hand shakes like a sewing machine, then chances are it's going to be very hard for you to draw a circle. So maybe you would use the enclosing box method to draw your circle. Okay? So look this up, the enclosing box method. And practice drawing freehand circles. Okay? All right. So there's some sketches that already exist here because I went over this with my 151 CAD 151 face-to-face students. What is a fillet versus what is a round? So if you have a T-shaped plate, this is a plate. Notice it has sharp corners, okay? sharp external corners and sharp internal corners. That's not necessarily the best way to design this, because the sharp corners create a safety hazard where it might puncture someone's hand if they handle the part. You're going to make the drawing. You need to design it in such a way that it's safe to handle. These are sharp points. So if you don't need the sharp points, sometimes it's best to put in a rounded corner. Okay, a rounded corner here, and then here, here. Okay, so another thing is the internal corners. Sometimes it's best to put what they call a fillet. And by the way, I have them labeled here. The external corners is called a round, the internal corners is a fillet. Notice when you put a fillet here how much material you add back to the part. You've actually increased the strength of the part by putting a rounded corner here versus a sharp 90. If you have a sharp 90 like this, you could possibly generate a crack. The crack will propagate across the part at these points of high stress concentration. If you apply a force here, here's a force here that you apply to your part, it could crack very easily. But by adding this fillet here, you've increased the strength of the part. And by adding the rounded corner, you improve the safety of the part. One of my students in the face-to-face class came up with a good example. So, Mr. Morris, what about a pipe that's welded to a plate? Well, the pipe has a fillet weld. Okay, so it's like a rounded internal corner. So the fillet weld, the bead of the weld itself is the rounded corner. Okay? All right. So this is for the benefit of my online class, because I talked about this in my face-to-face course. What is a pictorial drawing? A pictorial drawing is a picture, and they are primarily used for visualization. These are not 3D drawings. These are two-dimensional drawings that give the impression of being a 3D part, such as isometric. These are the most common types of sketches used in engineering courses, design courses, and CAD courses. They look like this. This is a step block. Notice the angle is 30 degrees with respect to the horizontal. Okay? And so this is a picture. It looks like a 3D part, but it's not. It's a two-dimensional drawing. But it gives the machinist or the technician or the technologist or the craftsperson an idea what the part looks like. They might see an oblique type of drawing. Now, this is the same part, but it's drawn differently. These are used not as much as isometric, but they are used periodically. Notice the angle that this line makes with the horizontal. Okay, so it's a little bit different, right? The angles. This is the 30 degrees with respect to the horizontal. This edge is parallel to the horizontal, but this line is at a 45-degree angle with the horizontal. Okay? All right. So the next thing I did is I drew the same part, the same step block, using two-point perspective. Now, we're not going to use two-point perspective in this class, but I wanted to give you, this is more what an artist would use, perhaps someone in the architectural field, maybe even in the civil engineering field, but it's the same part as I drew earlier. It's the same part, but it's drawn differently. Every line originates from these 2 points. Okay? Maybe you've seen the famous railroad track, right? The railroad track. It originates from 1 point. Okay? This is actually called a 1-point perspective. Okay? So again, we're not going to do this in this class, but keep in mind this is also it's also a pictorial. It's a picture. Okay, so what is an isometric drawing or isometric sketch? Well, an isometric sketch uses an isometric axis. Here is an isometric axis. These two lines here form an angle of 30 degrees with respect to the horizontal. This line forms a 90-degree angle with respect to the horizontal. Okay? This is what the graph paper looks like. Make sure that you get you some isometric graph paper. Remember, I just gave you a website a few minutes ago where you can go and download some of this paper and print it off. It's going to make it easier for you when you create these sketches. Note that the lines that are parallel in the actual object will still be parallel. Okay? And we're going to begin making some isometric sketches here very soon, both in by hand and also using AutoCAD. So orthographic projections are multi-view drawings. They're 2D drawings taken from viewpoints from various sides of an imaginary plastic box around an object. Okay? So here we have a block. And you can see the various surfaces have been labeled. Right? And if this is the front, let's say this block represents your house. And your line of sight is perpendicular to either A, B, or C. Those are the only surfaces you would see from the front view. And likewise, if you're on the side of your house, the right side of it, you would only see F and G. And then from the top, you would see surface D and E, as what's shown over here. Okay? Now, this is called orthographic projection, which we're getting ready to get into very heavily here. And you always want to show at least, sometimes you can get by with one view, like a gasket. As long as you tell the thickness of the part, you can get by with one view. Maybe even a cylinder. This is not how I would draw a cylinder, but you could put the length of the cylinder, and you could also put the diameter of the cylinder. Okay? So, anyway, make a long story short, 3 views are normally the number of views you would use to describe your part. It could be, if it's a complex part or a complicated part, you might need more than 3 views to describe it. Okay? All right. So here's that same block in a plastic box. Well, you can see through the plastic box, and you can see the block. They are projecting the surfaces onto the front view and the right side view and the top view. It says the views of the object inside the plastic box are shown as they would be seen by a viewer at an infinite distance from the box. So these little symbols here represent your line of sight. These are the surfaces you see. And on the right side view, these are the surfaces that you see as well. Okay? When you open up the box, you will see 6 views. Now, it's not normally necessary to show 6 views of a part. Again, unless it's a very complicated part and you need to show all 6 views. In most cases, you can get by with 3. That's usually the norm. Okay. Sorry that this drawing is all marked up, but we use this in my face-to-face CAD 151 course, and we were trying to find out what views or what dimensions are common between the various views. So here's what it says. With the box completely unfolded, so you unfold the box, The relationship between the 6 standard views is clear. Certain views have certain dimensions, height, width, and depth. If you look at the top view, you have the width and the depth. If you look at the front view, you have the height and the width. If you look at the right side view, you have the depth and the height. And the left side view, you have the depth and the height. And then the back view, you have the height and the width. The bottom, you have the depth and the width. So we don't need all these dimensions, okay? Basically, we might just need 3 views and just 3 overall dimensions to represent the overall height, width, and depth. There are other dimensions you would need to describe the part, but as far as the overall dimensions are concerned, you can get by with the front view, the right side view, and the top view, and lay out your dimensions as shown. Okay? So what are the common dimensions? In the top, front, bottom, and back, the width is the common dimension. In the front, left, right, and back, the height is the common dimension. See, it says the front, here's the front, height. The left is height. The right side is the height, and the back is the height. As far as the top, left, and right side and bottom views, the depth is the common dimension. Okay? All right. So I'm going to skip over these pages right here because it's just showing you various layouts. You always want to keep your views in line with one another. Like, for example, you want these edges to line up. And we're going to talk about this a little bit later when we talk about orthographic projection. Okay? All right. Earlier I said that you're going to need to look on the internet, mainly the alphabet of lines. And print you out a document that shows you the various line types. Today we're going to focus on 3, the visible line, the hidden line, and the center line. The visible line is used for the visible edges of the part. Hidden lines are used to illustrate features that you cannot see. Okay? And then center lines indicate the exact center of the hole and the arcs and other rounded features. So here's an example of a countered bored hole. A countered bored hole is a hole used to recess the head of a bolt, like in a plate or something, or on a deck or what have you. Notice these are the visible lines of the plate. Okay? Here are visible lines of the counterbore. Notice we have a dashed line here, though. Those are the hidden lines because you can't see that hole in that part. Unless, of course, you draw a cutting plane line through the center. And we're going to talk about this a little bit later on in the course, called section views. Here we have section lines indicating that the part has been cut. It's an imaginary cut. You don't really make a cut here, it's just an imaginary cut. So these lines that you see here are section lines. Notice now that my hidden lines are no longer hidden. They are a solid line because we are actually seeing the inside features of the block that we could not see before. Okay. We're going to skip over this page and this one and this one. Please read over those pages. But if you print out the alphabet of lines, I'll be happy. Okay, whatever one you want to print out, just go online, type in alphabet of lines, and look up images, and find a drawing that's going to show you the various line types. There is an order of precedence, though. A visible line has the highest precedence. So you would, if you have 2 lines coinciding with one another, let's say you have a hidden line and a visible line, the visible line is going to have precedence. If you have a hidden line and a center line coinciding with each other, the hidden line takes precedence. Center line has the lowest precedence. All All right. Now this is where we stopped in the face-to-face course, so this is where I want to pick up in the online class and the face-to-face class, because I'm going to post this on Canvas. Here we have an isometric, and we want to find out, or we want to create the front view, the top view, and the left side view here, not the right side, the left side. So I'm going to label my isometric. This is my front. This is going to be my right side view, and this is going to be my top. Okay? I like to start off with the front. So I'm going to count these little blocks. It might be hard for you to see, but we got 1, 2, 3, 4, 5, 6, 7. We have 8 units. So I'm going to put a point right here, and I'm going to go over 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8. Put a point there. I'm going to draw a line connecting the two. By the way, if you're not good at drawing freehand sketches, by all means, please consider using a straight edge or a scale or ruler to help you out. Now the height of this block, 1, 2, 3, 4, 5, 6, 7 is 7. So at this point, go up 7. 1, 2, 3, 4, 5, 6, 7. There's the point. Draw a line. Okay, like this. All right, from this point going over, I count 1, 2, 3 blocks. So I'm going to go over 3. Okay, then I'm going to come back down. 1, 2, 3, 4. 1, 2, 3, 4. These are kind of like doing puzzles. Okay. Then from here to here actually is what? 5. So we're going to stop right there and come down. Now that's what the front view looks like, but we can't see the notches. We can't see this notch, and we can't see this notch. So therefore we have to show a hidden line to represent the notches. Well, this notch is 3 units deep. 1, 2, 3. So I'm going to come down 3. 1, 2, 3, and I'm going to put a hidden line right here. Okay? Now this notch here, we're going to go over 1, 2. Come over 1, 2, and we're going to put a hidden line right there. Now, the method of projection. I'm going to take every one of these intersection points here and lightly draw a line upward like this, okay? Here's another intersecting point. Draw a line straight up like this, and then here's one. Draw a line like this, okay? So I'm going to start off with this point. So this would be that point right there. And again, we come 3 units, okay? And then we have 1, 2. Okay, so that's this surface right here. The notch itself is has a depth of 2 units, so we're going to come over 2 more. And then we're here at this surface here, which is also has a depth of 2. All right, so let me just. Okay, then we're looking down here at this surface here. So we know it stops at this line, so I'm going to extend this line here and here. Okay. We also know that we have this notch here, which this hidden line represents that notch, so I'm going to project this up like this. Okay. Now the depth of this notch is hard for you to see, but it's 1, 2 and a half. So if I start from the center line, go over 1 and a half, and then 1 and a half this way. It's going to look like this. Okay? So that's the top. Now we have to determine our left side. So there's the left side view right there. Looking from that direction, take all your points of intersection and project them over like this. Okay? Now, if you're looking from that side, you know that the depth of the total depth here is 6. So 1, 2, 3, 4, 5, 6. So we know that's the total depth of the part right there. Just going to box it in. All right. Now, we know that we have this notch that has a depth of 2 and a vertical height of 3. And we can get that from the hidden line as well. So it's going to look like this. Okay. And then, by the way, I came down just a little too far here. I'm sorry. Let me erase that line. Oops. Came down just a little too far. So it should actually be right there. Sorry about that. This is going to be a hidden line because we cannot see this surface right here looking from this direction. We cannot see this surface. Okay, remember the line of sight is perpendicular to that surface. So this is what this view would look like, okay, or this block would look like. I did leave 2 lines out, 2 hidden lines I need to add to this that represent this notch. And that's going to be right here. Okay, so pretty soon here I'm going to be asking you, I'm going to be giving you an isometric drawing that you're going to have to do by hand and also with AutoCAD. This is now a orthographic sketch. Okay? All right. Now, we're going to go on to another one. This one's a little easier. Imagine this once was a block, okay, a solid block like this. And we're going to cut off part of this block, okay? So again, I'm going to work with the front view, and we have the left side view and the top view. Okay? So if I start with my front view, count from this corner, 1, 2, 3, 4, 5. So I'm going to just, this point right here represents that corner. I'm going to go over 5. 1, 2, 3, 4, 5. I'm going to draw a line like this. What's the height of the block? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 to right there. I'm going to draw a line like this. Okay. Now we have 3 blocks this way. 1, 2, 3. Right here. Now we have to connect this point to this point. All right. So we're going to connect those points. Sorry, I kind of missed my mark there a little bit. Okay. Now, when you're looking at the block this way, you still can see this point and this point. Okay? So, if you're at this point right here, go over 3. 1, 2, 3. So, we're at this point 1, 2, 3, and put a point there. And you can also see this point from this one, from the front view. And that's over 2, because if you project this point back to that plane, you can see it's, well, actually, let's see. If we project over, it's actually 1, 2, 3. So 1, 2, 3. All right. And then we're going to draw a line connecting these 2 points. So we're going to draw a line here connecting those 2 points. Like that. Okay. All right. So that's what the front view looks like of that part. Now, I'm going to take my points of intersection and I'm going to project them up. So here's a point, project this up, this one, and this one, and then we have this one. Can't forget about this one here, right? And then this point, to project them up, okay? Like this. All right. So my top view, I'm going to start here at this point, which is right here. Again, these are like doing puzzles. Come over 3 like this. Okay, that's this line. and I'm going to count back the depth. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Put a point there. So this point right here is this point. Then we need to get to this point. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right there. Okay. And then it comes back here. Now, you guys can be a little neater than Mr. Morris is. I don't have exactly the best drawing board here by any means. So, at home you can use a straight edge, and I encourage you to do that, a ruler or something. Also, you can see this point from the top view, and it's 2 points over, or 2 units over from this point. So right here we have another point, which is this one. I'm going to extend that line like this. Where does it connect to? It connects, so it's going to connect right here. 1, 2, 3, 4, 5, right? So this is the top. This is the front. So it connects to this. This point right here is this point, which connects to this one. This is the same 2 points in the front view. This is that. This point right here is this point, and this point right here is this point. So we're going to connect these 2 points like that. And now these other lines, you need to make those very light. Okay, you don't want to make those lines too dark, because you start to erase them, you're going to smudge up your drawing. Now, the left side is just a rectangle, which is going to have a depth of what? 1, 2, 3, 4, 5, 6, and a height that's equal to 7. So it's going to look like this: 1, 2, 3, 4, 5. Excuse me. 1, 2, 3, 4, 5, 6, and then the height of it is 7. There's no hidden lines here at all. Not for this one. Okay? Now, if I was to label this, let's say this is surface A, and this is surface B, and this is surface C, and if I was to ask you to label those surfaces here, this would be C, this would be B, this would be B, and this would be A. Now let's say the back side of this, or not the back side rather, but the left side is D. This would be D here. Okay? Alright, so we have one more to do. And this used to be a cylinder. And they cut out 2 steps. They cut out a step here, and they cut out a step here. I can tell you from experience doing this one so many times that the diameter is 6. Okay? But I'm going to do the front view first. Okay, so this is my point right here. So this is going to be my point. Let me focus. I'm losing my focus here. Alright, so we're going to go up 1, 2, 3, 4. 1, 2, 3, 4. Then we're going to go over 1, 2, 3, go over 3 this way, and then we're going to go back up, because I told you it's 6 units in diameter. So we already have 4, right? Oh, wait a minute. Is that 4 or 3? 1, 2, it's 4. Alright, so we're going to go up 2 more like this, okay? And then the total length of this cylinder, step cylinder, is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, right here. Now, this little step that's 1 step high, or 1 block high, and it's 2 units this way. We're going to go up 1, and we're going to come back 2 like this. See, did I miscount here? Let's see. That was 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that looks right. I think my problem might be back here. 1, 2, 3. Is that right? 3, 1, 2, 3. Yeah. And then we have. I think what's bothering me about this. This is 2, and that's 3. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. I think this is actually 2 here. So it doesn't really look like a cylinder from the front view here. So how do we know it's a cylinder? Because when I draw the top, it's going to look like a rectangle as well. It's going to look rectangular. It's not going to look circular, because I'm going to project all these points up. This one very lightly. Draw these lines very lightly. Okay. And I'm going to draw a center line here, like this. And remember I said it's 6. So I'm going to come over 3 this way, and 3 this way. Okay. Now if you look at this block here, it's only, the depth of it is only 1, 2, 3, 4. So I'm going to come over 2 this way and 2 this way. So that's the lower step. Okay. That's this step. So if I call this A, that's A. Then we're at 6. Okay. Now the last part of this is going to be a little difficult, because if we stopped at 3, it would be perfectly at the diameter of this, but it's not. It's up. So let me show you what we got to do here. This is actually going to be the center line right here. This is actually the center line. I'm going to project over, and I'm going to come out 3 here. You could draw the enclosing box here if you wanted to. So this is the enclosing box. Do it very lightly, and we're going to draw a circle like that. Okay. Now right here at this edge, we're going to project over. From the left side, we can see that step right there, but we can't see this one. So that has to be a hidden line. Okay, that's all fine and dandy, but the top view is not done yet. We know we have a line here, but what about here? If you look at this, it's 1, 2, roughly about 2.5. So it's going to look like this. Okay, without. So let me it's going to look like this. I want you to pay close attention now to this and this. Okay, that line doesn't go all the way across. It would if this step was only 3 units tall, but this step is 4. So you do see a little bit of that curved edge right there. So it does not, that line does not continue. And so there's a gap there. Okay, that's our step. So let me label it. If that's A, this is B, this is C, this is B, this is C. Okay? Alright, so I hope this helps some. Please come talk to me. If you're struggling with the sketching part, I'd be glad to talk to you about this PowerPoint. Again, this was a test to see how well this video turned out. I hope it turned out okay. Thank you for your time, and we'll be talking to you soon. Thank you.